Good afternoon friends, and welcome back again to another session of Mathematics class 12, and today we are going to discuss the matrix second part, which is about the Martin's rule. We have already uploaded the first part and this is the second part, that is the Martin's rule. We are going to study Martin's rule today. This is of the chapter matrix. We are dealing with the chapter matrix, class 12 mathematics matrix. So as you all know, you are watching Parijat sir classes. So before I proceed, it's a request from my side, please like, share and subscribe my channel. Like, share and subscribe my channel so that I get the motivation to make more and more videos for you. So let's move ahead with this session of the matrix, how to solve the simultaneous equation using matrix. We will be dealing how to solve simultaneous equations using matrix. So first of all, watch here. Please see the rules, what we are going to discuss today. First point: obtain the system of equations and express it in the matrix equation form. In this form we have to express it. Okay, so first we will express it in the matrix form in this pattern. We will all be discussing it, so please don't worry about it. Find modulus of A. Modulus of A, how to find, already I have discussed. If modulus of A is not equal to 0, then please understand it is the solutions are consistent with unique solution. It is a unique solution and it is a consistent with unique solutions. This is the thing which you have to remember. Okay, so let us highlight it. Consistent with unique solution. Clear? And if it is that, in that case, then find out the A inverse of the matrix. How to find A inverse? Adjoint of A by the mod of A. Adjoint of A by the mod of A. Okay, and then find out the X using this formula. If mod A is 0, you have to remember, if mod A is not 0, this is the condition. If mod A is not 0, if mod A is 0, then the system of solutions will be inconsistent if adjoint of A into B is not equal to 0. Mind it, inconsistent if adjoint of A into B is not equal to 0, and it has no solutions, and it will have infinitely many solutions if adjoint of A into B is 0. Please understand, if adjoint of A into B is 0, it has infinitely many solutions. If adjoint of infinitely many solutions, when is it possible? It is possible when adjoint of A into B is 0. Similarly, inconsistent, when is it possible? Inconsistent is possible when adjoint of A into B is not equal to 0. So these are the very important thing. And if it is mod A is not equal to 0, then you have to find A inverse. How? This is the formula for finding the A inverse. And if you can find A inverse, then you can find the value of X using this formula. So this is the basic approach of this chapter, simultaneous equations. Now when we will be solving it, you will be able to understand it in a better way. So let's get started with the chapter. Using matrix method, solve the equation. So this is the equation. So from this equation, first find your matrix A. So A will be, this is 1 minus 2, So 1 minus 2, and from here you will take minus 3 and plus 5. So this is minus 3 and plus 5. Then write xy. This is your matrix X. First one is your matrix A, and then 4 and minus 7 makes matrix B. So this is the matrix B. Okay, so now what you have to do? So you have to now find out the modulus of A. Modulus of A. So how to find the modulus of A? 1 into 5 minus this into this. This diagonal, this diagonal. So please watch here. I'm showing you again. So it is minus 2. Let me write it here first. So how to find the modulus of the matrix? First you will do 1 into 5, and then you will do minus 3, minus of this into this, minus of this into this. Clear? So this gives you the value mod A. So this is the value of mod A. Clear? Now we have to find out, that is mod A. See, it's not coming 0. So I told you that if mod A is not 0, if mod A is not 0, if mod A is not 0, it is what? Consistent with unique solution. Consistent with unique solution. So please understand these things. If mod A is not equal to 0, then it is consistent with unique solutions. That means you can find the solution of this. That means you can find the solution of this. So this is what we are going to study now, that how to find this equations. So let us see. That means if mod A is not equal to 0, if mod A is not equal to 0, it is consistent and unique solution. Please see this. Clear? So now let's move on to the solution. So mod A has come not equal to 0. That means it is a unique solution. Now how to find X? X will be A inverse of B. So how to find the A inverse? First find the cofactor. So for the cofactor, please remember that put the sign like this: plus, minus, minus, plus. For a 2 by 2 matrix, for a 2 by 2 matrix, please put the sign plus, minus, minus, plus. Put the sign first. Okay. So now cofactor matrix, how will you find? For this position, please watch. For this position, you have to leave this row and this column. So what is left? 5 is left. So write down 5 here with a plus sign. Clear? Next, for this position, so leave this row and this column. So what is left? Minus 3. So write it here, but the position has a minus sign, so write it with a minus sign. Clear? Next, for this position, so leave this row and this column. So what is left? Minus 2. So in place of minus 3, write minus 2, but there is a minus sign here. So give minus sign in front and write minus 2. Next, for this position, leave this column and this row. So what is left? 1. So for this position you will write 1, but there is a plus sign, so write it with a plus sign. That means this becomes ultimately this matrix. So this is how you find the cofactor matrix. This is how you find the cofactor matrix. Now, how to find the adjoint of a matrix? Transpose the cofactor matrix. Transpose the cofactor matrix. That means interchange the row and column. The first row becomes the first column. The second row becomes the second column. So this is how you find the transpose of a matrix. This is how you find the transpose of the matrix, right? Now, how to find the A inverse? It is adjoint of A by mod of A. So this is the adjoint matrix, and mod of A, this is the adjoint matrix, and mod of A was -1. Mod of A was -1. So -1, and this is the matrix. That means it becomes -5, -2, -3, -1. So this is the A inverse matrix. Now, how to find the X, that is A inverse of B? So this is the XY matrix, A inverse into B. So how to multiply? As I told you, how to multiply this matrix. So first of all, what you have to do is take the row -5 into 4 plus -2 into -7. So you will get this. Okay. Second, you will now take -3 into 4 plus -1 into -7. So this is how you will get. Okay. So calculating this, we get -20 plus 14, which is -6, and -5. That means our X is -6 and Y is -5. Clear? X is -6, Y is -5. Now let us come to the part where we have got 3 equations. So again, AX equal to B. What is our A? It is 1, 1, 2. So this is the first column. Then is +2. Y is missing here. So 0, and then -3. Third, it is 1 and 3, and then Z is missing in the third line. So 0. X, Y, Z. This is our B matrix, 7, 11 and 1. Okay. So now find the modulus of the A. So I told you, for a 3 by 3 matrix, please watch it. For a 3 by 3 matrix, how to do? If it's a 3 by 3 matrix, then how to put the sign? Please watch. Plus, minus, plus, minus, plus, minus, plus, minus, plus. And for a 2 by 2 matrix, it is plus, minus, minus, plus. So please remember this. For a 3 by 3 matrix, you have to put it like this. So let's see now. So this is a 3 by 3 matrix, plus, minus, plus, minus, plus, minus, plus, minus, plus. So when I take +1, then I cannot take this row and this column. So what is left is this one. So watch how I have written. It is 0 into 0, -3 into -3. So this is how I have written. So +1, here is +1. So you cannot take this row and this column. So what is left? This is left. That means 0 into 0 minus -3 into 3. Clear? Next, if I take -2, then you cannot take this row and this column. So what is left? What is left is this, this, this and this. So you have to do 1 into 0 minus 3 into 2. So here I have done for minus 2. Clear? Here I have done it. Next, for plus 1, you cannot take this row and this column. So what is left is this is left. So it will be 1 into 3 minus 2 into 0. So here I have written for plus 1. Okay. So this is how we find the modulus of a matrix, and then we calculate and we find the mod. So it is coming 18, which is not equal to 0, and if it is not equal to 0, already I have discussed, it is a unique solution. It is a unique solution. If it is not equal to 0, it is a unique solution. Please note it. It is a unique solution. Now we have to find the cofactor of A. So first give the sign plus minus plus minus plus minus plus minus plus. So as I told you, if you take plus 1, then you have to take 0 3 minus 3 0. This is what you have to take. You cannot take the row and you cannot take this column. So you have to take this part, and here I have written. Similarly, if you take this position, then you cannot take this row and this column. So you have to take 1 3 2 0. So here I have taken. Next, if you take this position, you cannot take this row and this column. So you are left with only this part. So here I have written. Similarly, if you take this position, you cannot take this column and this row. So what is left? 2 1 3 minus 3 0. So here I have taken. If you take this position, you cannot take this row and this column. What is left? 1 1 2 0. So here I have taken. If you take this position, you cannot take this column and this row. So what is left? 1 2 2 minus 3. 1 2 2 minus 3. So this is that thing. If you take this position, you cannot take this column and this row. You have to take this part. So this is I have written here. If you take this position, you cannot take this row and this column. So what is left? 1 1 1 3. Here I have taken. And if you take this position, you cannot take this column and this row. So what is left? Left is this part. 1 2 1 0. Okay. Now we have to calculate it. So it is 3. It is 0 minus of minus 3, which is minus 9. Then there is a minus in front, so it is 0 minus 6, and there is a minus outside. Then it's plus minus 3 into this is 0. Then is minus, it is 0 minus of minus 3. See, all the calculations are shown. Then it's plus, it is 1 into 0 0. Then 2 into 1 is 2, minus 2. Always these two multiplied first. These two are multiplied first. Then you have to give a minus sign, and then these two multiplied. These two multiplied. That is the rule. These two multiplied, give a minus sign, then these two multiplied. This is the logic. So next is again, see, minus sign, 1 into minus 3, this is minus 3 minus of minus 4, so this is written here. Then is plus sign, this is 6 minus 0. Then is minus sign, which is 3 minus 1. Then is plus sign, which is 0 minus 2. Now if we calculate this, we are getting, if we calculate this, the matrix is becoming, this is the matrix, cofactor matrix. Now in the cofactor matrix, now we have to find the adjoint matrix. How to find the adjoint matrix? It is the transpose of the cofactor matrix. That means, now transpose means you will interchange the row and the column. The first row will become the first column. The second row will become the second column. The third row will become the third column. So this is how you get the transpose. This is how you get the transpose of the matrix. Okay. Now how to find the A inverse? How to find the A inverse? It is adjoint of A by mod A. So this is the adjoint of A and this is the mod A. Okay. This is calculation of the A inverse. Now how to get X, which is A inverse into B? So this is our A inverse into B. So this is the matrix B. Already we have done this. So now we will multiply. So what is the rule? It is, let me show you, it is 9 into 7 plus minus 3 into 11 plus 6 into 1 is this one. Second, six into 7 plus minus 2 into 11 plus minus 2 into 1, and this is that part. Next, minus 3 into 7 plus 7 into 11 plus minus 2 into 1, and this is this part. So now on calculations we are getting this as 63 minus 33 plus 6, which is 36, and this is 18, this is 54, dividing by 18 we are getting this. This was the matrix X, which is actually X, Y, Z. So X is 2, Y is 1, Z is 3. So this is our solution. Clear? This is our solution. So now let's see the next part, friends. This we have already done. Let's see. Show that the following equations are consistent. That means, first of all, make your matrix. Okay. So 2x minus y plus 3z. That means I will take 2 minus 1 and plus 3 in the first row. Then it is 3x plus 2y minus z. So I will take 3 plus 2 and minus 1 in the second row. And then I will take 4 plus 5 and minus 5 in the third row. So this is my matrix A. This is my matrix A. Clear? And then X, Y, Z, and the B matrix is 5, 7 and 9. This is my B matrix. So now we have to find the mod A. As I told you that always give the signs plus, minus, plus, minus, plus, minus, plus. I already showed you that if you take plus 2, then you have to take this part for calculations. So it is minus 10 minus of minus 5. Clear? This is that part. Next, if you take minus 1, so there is a minus in front, So this is that minus, this is that minus, minus of minus 1. So you have to take this, this, this and this, and then multiply 3 into minus 5 and minus 4 into minus 1. Next, if you take this part plus 3, then you have to take this part 3 into 5 minus 4 into 2. So now on calculations we are getting mod A as 0. Now if mod A is 0, please note it, it is a singular matrix. If mod A is 0, mod A will be called as a singular matrix. If mod A is 0, mod A will be called as a singular matrix. Please note that. So now how to find? We'll find adjoint of A into B. Now if adjoint of A into B is not equal to 0, it will be inconsistent. And if adjoint of A into B is 0, it will be consistent with infinitely many solutions. So let us now find out. So this is the first. For finding the adjoint, we have to find the cofactor. I already taught you how to find the cofactor. Okay, please refer to that. This is how to find the cofactor. Choose the positions. You cannot take the row and column first. For this, if you want to find the cofactor of this, you cannot take this row and this column. You have to take this part. Clear? Similarly, if you are choosing this position, you cannot take this row and this column. You have to choose this, this, this and this. Similarly, if you want to find for this cofactor of this, you cannot take this row and this column. You have to take this part. Similarly, if you want to take cofactor of this, you cannot take this column and this row. You have to take this, this, this and this. And if you want to find the cofactor of this, you cannot take this column and this row. You have to take this, this, this and this. Similarly, if you want to find the cofactor of this, you cannot take this column and this row. You have to take this, this, this and this. If you want to find the cofactor of this, you cannot take this column and this row. You have to take this part, these four. If you want to find the cofactor of this part, you cannot take this row and this column. You have to choose this, this, this and this. And finally, if you want to find the cofactor of this, you cannot take this column and this row. You have to take this part. So using this concept, we found the cofactor of this. And now we are multiplying it. 2 into 5, you have to multiply this also, please remember. 2 into minus 5, minus of 5 into minus 1. Okay, first multiply these two, then multiply these two and give a sign in between minus. Give a sign in between minus. So similarly we are calculating all the parts. So this will be minus 15 and this is minus 4. The sign is minus, so it becomes plus 4. Similarly this will be 15, this will be 8, so 15 minus 8. This will be plus 5 and this is 15, so 5 minus 15. This will be minus 10, this is 12, so minus 10 minus 12. This will be 10 and this is minus 4, so 10, it will become plus 4. This is 1 and this is 6, so 1 minus 6. This will be minus 2 and this is plus 9, so minus 2 minus 9 it will become. This will be 4 and this is minus 3, so 4 it will become plus 3. So then the values become this. So now find the adjoint of A, which is the transpose of this cofactors. That means transpose means the row, first row becomes the first column, the second row becomes the second column, the third row becomes the third column. And now find adjoint of A into B. So this is adjoint of A matrix into B. So this is how you are multiplying. So how will you multiply? As I already discussed, you will take minus 5 into 5 plus 10 into 7 plus minus 5 into 9. So this is that first line. Now we will do 11 into 5 plus minus 22 into 7 plus 11 into 9, and this is that second line. Now we will do 7 into 5 plus minus 14 into 7 plus 7 into 9, and this is that third line. So now we are calculating this, we are getting this as 0, this is coming 0, this is coming 0, this is coming 0. So adjoint of A into B came 0. So as I already discussed, if adjoint of A into B, if adjoint of A into B comes 0, then we have infinitely many solutions. Please note this. Infinitely many solutions. Clear? So that means this should have now infinitely many solutions. Adjoint of A into B came 0. Now how to find that many solutions? If it comes infinitely many solutions, how to calculate that infinitely many solutions? So please now note it, that put Z equal to K, put Z equal to K in the second equation, in equation 1 and 2. So if you put Z equal to K in equation 1 and 2, so this was our equation C, this was the equations, these were the equations. If Z becomes K, it becomes 5 minus 3K. If Z becomes K, it becomes 7 plus K. If Z becomes K, it becomes 9 plus 5K. So now the equation becomes, the first equation becomes 2x minus y equal to, the first equation becomes 2x minus y equal to 5 minus 3K. Second equation becomes 3x plus 2y equal to 7 plus k. Now again see, it is a 2 by 2 matrix. So 2, 3, minus 1, and plus 2 will make it A. So this is our A matrix. And X into Y. And now our B matrix. What is our B matrix? Our B matrix will be 5 minus 3k and 7 plus k. This is our B matrix. Okay, so AX equal to B. So this is our B matrix. Now we'll find mod of A. So how to find mod of A? 2 into 2 mod of A. How to find this? 2 into 2, 4, and this is minus 3. So 4 minus of minus 3 is 4 plus 3 is 7, which is not equal to 0. And if it is not equal to 0, we know that it will be a unique solution, right? It will be a unique solution. So now find the cofactor matrix. First find the cofactor matrix. So first of all, give sign. It is 2 by 2 matrix. I already told cofactor matrix plus minus minus plus. So for this position you cannot take this row and this column, so this is left, and this position has a plus sign, so plus 2. Now for this position, you cannot take this column and this row, so this is left, and this position has a minus sign, so it is minus 3. Now for this position, you cannot take this column and this row, so what is left? Minus 1. That means here comes minus 1, and this already has a minus sign, right? Now for this position, cannot take this column and this row, so left is 2, so here comes 2, and this position has a plus sign. Now it becomes this, so it becomes plus 2 minus 3 plus 1 and 2. Now find the adjoint of A, which is done by finding the transpose. So first row will become the first column, second row will become the second column. Clear? Now find the A inverse. It is adjoint of A by mod A, so this is the adjoint of A, and mod A is 7. So now find X, which is A inverse of B. So this is the A inverse matrix and into B. So how will I do? How will I do the calculations? So I will do 2 into 5 minus 3k plus 1 into 7 plus k here. And next I will do minus 3 into 5 minus 3k plus 2 into 7 plus k, and here is that. So now calculating it, we are getting this. If we calculate it, we are getting this. Okay, which is this. That means X is our this and Y is our this. So now we got the solution as X is our this is our X, as you can see. So now see, this is the 7k, so that is, this is our X and this is our Y, and that was our Z. Now if I take K is what? K is a real number. What is K? K is a real number. That means you can choose k as any value, keep putting, so you will keep getting infinite solutions of xyz. Infinite solutions of xyz. Clear? This is how you solve this type of sum. Next, let us move ahead and see the next sum. So the next sum says A is this matrix, find A inverse and hence solve the system of linear equations. Clear? So first of all, using this matrix we have to find the A inverse. So for A inverse, first I have to find the cofactor matrix. So for cofactor matrix, first give the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. Find the modulus of the matrix, so which is 1 plus 1 into, you will take this part, okay, so here it will be 1 into 1 and minus 3, so 1 minus of minus 3, which is plus 3. Next I will take this one, minus of minus 1, which is plus 1. So I will choose this into this, minus this into this. Next I will choose this one. So I will take this into this, minus this into this. So we are getting it as 10, which is mod of A is coming 10, which is not equal to 0. Clear? Now find the cofactor matrix. So for the cofactor matrix, for this position, I will take this part. So here I have taken, which is 1 into 1, and this is minus 3. So we put a minus sign, so it becomes 1 plus 3. Next, for this position, I will take 2. I will take 2 into 1, 2, and this is minus 3. So 2 plus 3 it will become, and this position has a minus sign. Now for this position, which has a plus sign, I will take 2 minus 1 with a plus sign. Now for this position, which has a minus sign, I will take minus 1 into 1 and this in 1 into 1. Okay, so here is this, and for this position I will take 1 into 1 minus 1 into 1. Now for this position, which has a minus sign, so here is a minus sign, and then I will take 1 into 1 minus 1 into minus 1. For this position, which has a plus sign, I will take minus 1 into minus 3 and 1 into 1. These two will be subtracted. For this position, which has a minus sign, I will take 1 into minus 3 minus 2 into 1. And for this position, which has a plus sign, I will take 1 into 1 minus 2 into minus 1. So calculating this, we get this matrix, cofactor matrix. Then adjoint A is the transpose of the cofactor matrix, that is row. First row will become the first column, second row will become the second column, third row will become the third column. This is the adjoint matrix. And now A inverse is adjoint of A by mod A. This was mod A, we did this. So now please watch one thing, that is we got the A inverse as this matrix. We got A inverse. Please keep a watch of this. Now what was our equation? If I see, our equation was this. So our matrix will be 1, here is 1, plus 2, plus 1, minus 1, plus 1, plus 1, plus 1, minus 3, plus 1. So see, using this we are making a matrix here, here, 1, 2, 1. So if you can see, using these solutions, using these solutions, we are making, using this solution we are making the matrix. With this part we are making the matrix. So this is our matrix, XYZ equal to 402. 402 was the B matrix. Okay, what is the B matrix? The B matrix is this: 4, 0 and 2. This is the B matrix. Clear? So now watch one thing. If I do the transpose of this matrix, if I do the transpose of this matrix, A transpose X equal to B, if I do the transpose of modulus of the transpose matrix, and if I do the modulus of A, we are getting 10. That means if I take the transpose of this matrix and if I do the modulus of the previous matrix, this is our matrix A. Okay, if I do the modulus of that and if I do the modulus of the transpose, we are getting 10. So the system of equations are consisting of and consistent and have a unique solution. That means, so how to do it? X will be, I can take, instead of A inverse B, I can take A transpose B inverse, means A inverse transpose, and instead of this A inverse I have used this inverse, this particular inverse into B. Clear? And now we are multiplying. So here we are multiplying. Four into 4 plus minus 5 into 0 plus 1 into 2 is this line. And then 2 into 4 plus 0 into 0 plus minus 2 into 2 is this line. And then 2 into 4 plus 5 into 0 plus 3 into 2 is this line. So we are doing the calculations and we are getting X as 9 by 5, Y as 2 by 5 and Z as 7 by 5. So this is the solution. Next, let us see. Find the product of this and this. Suppose we name the matrix as C and this is as A, and use it to solve the equation. So these are the equations given here. So let's see the equations. So these are the equations. Okay, and which is our B? Our B is this, this and this. Okay, so let's now see. So telling first use the product. So let us do the product of this. So how to do the product? 4 into 1 plus 4 into 1, this 4 into 2. So here we are writing this. Now we will do minus 4 into minus 1 plus 4 into minus 2 plus 4 into 1, which is this. Now we will do minus 4 into 1 plus 4 into minus 2 plus 4 into 3, and which is this. Now we will do minus 7 into 1 plus 1 into 1 plus 3 into 2, which is this. Now we will do minus 7 into minus 1, 1 into minus 2 and 3 into 1, which is this. And now we will do minus 7 into 1 plus 1 into minus 2 plus 3 into 3, which is this. And now we will do 5 into 1 plus minus 3 into 1 plus minus 1 into 2, which is this part. And now we will do 5 into minus 1 plus minus 3 into minus 2 plus minus 1 into 1, which is this part. And now we will do 5 into 1 plus minus 3 into minus 2 plus minus 1 into 3, which is this. And now solving it, we get it as this. 8 comes out, so it becomes 8i. That means CA, we got CA as 8i. We got CA as 8i. Okay, so I will be equal to 1 by 8 CA. So I is 1 by 8 CA. And please remember this, that if you multiply any matrix with its inverse matrix, it is always I. So here we are writing I means 1 by 8C into A. That means this is my A inverse. This is my A inverse. Okay, so this is my A inverse matrix. So from the equations which they have given, as I showed you, these are the equations. From the equations which they have given, I can make this matrix AX equal to B. So X will be A inverse, and A inverse already we found. This is my A inverse in the previous. We found this. So now A inverse into B. So now we will multiply. Minus 4 into 4 plus 4 into 9 plus 4 into 1 is this. Now we will do minus 7 into 4 plus 1 into 9 plus 3 into 1, which is this. Now we will do 5 into 4 plus minus 3 into 9 plus minus 1 into 1, which is this. And now calculations, we get this. So this is our X, Y and Z solutions. Clear? So now let's see this. Now what we are doing is that we are converting the problem sum into the matrix form. Okay, this is the problem sums converted to the matrix form. So see, here they have given that the sum of the sum of three numbers is 6. So let the numbers be x, y and z. Sum of the three numbers is 6. Sum of the three numbers is it will be, I think, 1 minute. There is some misprint here, so let me correct it. This is 1. Okay. If we multiply the third by 2, here is the third by 2, and add to the first, the result is 7, we get 7. Then they are telling by adding the second and the third, we added the second and the third to 3 times the first, the result is 12, we get 12. So these are our 3 equations. So here we can see that our matrix A will be this 1 1 1 1 0 2 3 1 1, and it will be, so from here we can see that the 3 solutions, and now we already know how to solve it. We already know that how to solve it. So this is our matrix A, x y z 1 7 2. Now we have to find the mod of A. As I told you, we'll calculate the mod of A. Mod of A is not equal to 0. That means it will give a unique solution. So here we are finding the first cofactor matrix, and then we'll do the adjoint of A, which is the transpose of the cofactor matrix. Then we will find the A inverse. Already I showed all of these to you. Then we will do this A inverse into B. We got this. Then x y z will be coming in this way. So this is already we have done how to solve the linear equations, 3 linear equations. Okay, so it is just the framing of the sum into the matrix form. Next they are telling you have to make a mixture of 3 foods, A, B and C, and the 3 foods should have the nutrients P, Q and R. How? The ounces are given that for P in the food A you have to give 1 ounce, Q nutrient as 2 ounce, R nutrient as 5 ounce. Similarly for food B you have to give P nutrient as 3 ounce, Q nutrient 1 ounce, R nutrient as 1 ounce. For the food C you have to give P nutrient as 4 ounce, Q nutrient as 2 ounce and R nutrient as 1 ounce. Okay, so suppose we make, they are telling that total P nutrient is 8 ounce. Total of this P nutrient should come 8 ounce, and this should come 5 ounce, and this should come 7 ounce. So let I make X quantity of A food, Y quantity of the B food and Z quantity of the C food. So this is how I will make 1x plus 3y plus 4z, and total should give me 8. Similarly 2x plus 1y plus 2z should give me 5, total is 5, and 5x plus 1y plus 1z should give me 7. Now we already know how to solve this matrix. So solving this matrix you can find out your x, y and z. That is our requirement. Clear? So friends, with this we have finished the Martin's rule solution, how to solve the Martin's rule, and I hope you have understood. So please keep following the method by pausing the video, and please keep solving it along with me. Then only you will be able to solve it with less doubts. And for understanding this, I would suggest you please go through the video 2-3 times. because the more you go through the video, the more you will be able to understand it properly. Okay, so again, wishing you all the best, and please, it's a request again that please keep watching Parijat sir classes, and like, share and subscribe. Definitely please like, share and subscribe my channel so that I can make more and more videos for you. Okay, so it's once again thank you from my side for watching this video. Thank you so much, and please keep watching Parijat sir classes. Thank you so much.